Have you ever had that feeling, that knot in your stomach when you know a really critical application, one that just cannot go down, needs a huge upgrade, or even a full migration? It feels like, I don't know, changing a tire on a race car while it's still zooming around the track. It's terrifying, frankly, especially when that application holds, vital customer data and you absolutely cannot afford to lose a single transaction or have even a blip of downtime. Well, today on the deep dive, we are putting on our virtual pit crew helmets, I guess, and tackling exactly that kind of high stakes situation. We're going deep into the complexities of migrating a stateful .NET application, moving it from traditional Azure virtual machines over to the more modern world of Azure Container Apps. And the main goal here, the absolute non-negotiable, is achieving zero downtime through the whole process, especially when you're dealing with critical bits like SQL Server always-on availability groups.
Right. And our mission for you listening in is really to give you a shortcut, a way to get up to speed on this pretty advanced cloud migration strategy without wading through, dense documentation for hours. We've basically distilled a detailed technical guide about this exact migration down to the most important insights. The idea is you'll walk away with a clear roadmap and maybe a few of those aha moments. You'll see how a task that seems incredibly demanding, maybe even impossible, can actually be done seamlessly. It's about seeing what's possible.
Okay, let's really dig into this then. A stateful .NET app, I mean, that sounds like it comes with a lot of baggage, doesn't it? So why is migrating stateful applications, especially the ones using something like SQL Server, always on AGs, why is that so much harder than, say, just moving a simple static website? What makes zero downtime such a tightrope walk here?
Yeah, that's exactly the right place to start, because it really gets to the heart of the difference. When we say stateful, we're not talking about an app that just handles a request and forgets everything immediately after. No, we mean applications that need to remember data or remember user interactions across multiple requests or sessions. Think about your online banking site, right? It knows you're logged in, it knows your balance, or maybe an e-commerce site that keeps track of your shopping cart. Losing that state, even for a moment, could mean lost data, users getting logged out, dropped shopping carts, interrupted business processes. It's bad news. For these kinds of apps, any downtime is it's usually completely unacceptable.
Right, unlike a static site, which is more like a brochure. If it's down for a second to update, no big deal, really.
Yeah. Exactly. A static site is like that billboard analogy. Swap the ad, nobody really loses anything crucial. But a stateful app, it's more like a live phone call. If the line drops, you lose the context, you have to start over. And then you add SQL Server always on availability groups AGs into the mix. Now you're talking about the core data storage itself. AGs are fantastic, make no mistake. They give you high availability, disaster recovery for your databases. They make your data layers super resilient. But the real tricky part, the tightrope walk you mentioned, is coordinating the application's move while ensuring that database stays continuously available and then gracefully switching the app's connection over. That's the challenge.
Okay, so how do you actually pull that off? Maintain the app and the database connection without dropping anything?
Well, it really boils down to three key strategies working together, almost like a three-legged stool. First, you have to containerize the application properly, get it packaged up for this modern environment. Second, you need to cleverly use Azure Container Apps' own features, specifically its revision-based deployments, which are built for smooth updates. And third, you have to carefully, very carefully, orchestrate the SQL Server AG failover, so it has minimal, ideally zero impact. Each piece needs to mesh perfectly with the others.
All right, let's take that first piece then. Containerizing the app. Now, on the surface, that sounds like, okay, Dockerize it, right? Put it in a container. But for a stateful .NET app needing zero downtime, I'm guessing the devil's in the details. And how do Azure Container Apps actually deliver that zero downtime thing on the app side? It sounds a bit like magic.
Yeah, it's fair to be a bit skeptical. The concept is simple, containerization itself. But you're right, the details are absolutely crucial, especially when high availability is on the line. Like when you're writing your Docker file for the .NET app, you often have a choice. You might need Windows containers if your app relies heavily on some Windows-specific feature, but often you can go with Linux containers, and they're usually preferred, actually. They tend to be more cross-platform friendly and generally have a smaller footprint.
Smaller footprint meaning faster starts, less resource use.
Exactly. Faster startup times, lower costs in the cloud, little optimizations that add up. But here's a really critical part, something that sometimes gets overlooked even by experienced teams. Health checks. These are non-negotiables. We're talking mainly about two types here, the readiness probe and the startup probe.
Okay, probes, what do they do?
All right, so the readiness probe, think of it as an endpoint, like a specific web address or a network port check that your application provides. It's the app raising its hand and telling the system, Azure Container Apps in this case, hey, I'm genuinely ready now. I can take real traffic. My internal stuff is running. Database connection is good. Cache is warm. It's the signal that it's truly ready for prime time.
Got it. So it prevents traffic hitting an app that's not quite ready.
Precisely. And the startup probe complements that. It runs first, especially when a container starts up initially or restarts. Its job is to make sure the container is fully initialized, all its essential services are running, and it's warmed up before the readiness probe even begins checking. This stops the system from sending traffic too early, like when the app process is still loading configurations or connecting to the database. That would cause errors, wouldn't it? Or look like downtime to users.
Ah, okay. So startup first, then readiness.
Exactly. And the secret isn't just having these probes, it's making them smart. A readiness probe that just checks if the web server process is running. That's not enough. What if the database connection is down? The probe needs to be intelligent enough to check if the app can actually do useful work.
Makes sense. Check dependencies, too.
Right. Once you've got your image built with good, intelligent probes, you test it thoroughly, then push it to a secure place like Azure Container Registry. Standard stuff.
Okay, so that's the container side sorted. Now, the Azure Container Apps magic for the zero-downtime deployment. You mentioned revisions.
Yes. The secret sauce, if you like. First step, usually, is provisioning your Container Apps environment inside your existing virtual network, your VNet. Think of the VNet as your private network neighborhood where your current VMs live. By putting the Container App environment in the same VNet.
It can talk directly to the existing stuff, like the SQL AG listener.
Bingo. No complex firewall rules or public internet hops needed for that core communication. It simplifies things and improves security. Then comes the deployment magic. Using single revision mode in Azure Container Apps. What this does, basically, is automate a deployment pattern often called blue-green.
Blue-green, I've heard of that. One live version, one new version.
That's the idea. When you deploy a new version of your app, maybe just by telling Container Apps to use a new image tag, it doesn't just kill the old one and start the new one. No. Instead, it spins up the new instances, the new pods, with your updated code. That's the green environment. It starts them up alongside the currently running version, the blue one. Then, crucially, it runs those health checks we just talked about, the startup and readiness probes, on the new green instances.
Ah, so it waits until they're proven healthy.
Exactly. Only when those new pods signal they're fully ready and healthy does Azure Container Apps automatically and gracefully switch the incoming traffic over from blue to green. And then, once the new green version is handling traffic stably, it deprovisions the old blue revision. The result: no dropped requests, no visible downtime for your users during the entire application update. It's really slick.
That does sound pretty good. Automating blue-green. What else do we need to configure there?
A couple of key things in the container app setup. You'll set your ingress, how traffic reaches the app to match your network, maybe external or internal. And very importantly, you set your min and max replica count. You need at least 2 replicas, so min replica set to 2 or more.
Why 2?
Because that allows for rolling updates even within a revision, or ensures high availability. If one instance needs to restart or fails, the other one is still there serving traffic. It prevents a single point of failure at the instance level. With these settings, just deploying a new image tag triggers this whole seamless automated process. Azure handles the complex orchestration for you.
Okay, I'm sold on the app side. Those probes and the single revision mode sound like a solid plan for the application layer itself. But the database, you mentioned it earlier, that's where things feel really, really risky with a stateful app. How do you possibly make sure that SQL Server always on availability group switches over gracefully without, breaking all the active connections? That feels like the real high wire act.
You're absolutely right to focus on that. It is often the most critical part. And yeah, it can feel intimidating. The database is the heart, like you said.
Yeah.
But the good news is it's manageable, very manageable, with the right preparation. First, before you even think about migrating the app, you need to sort out the AG setup. Critically, the AG listener needs a DNS name. And that DNS name must be resolvable, must be reachable from both your old VM environment and your new container app network space within the VNet.
So one consistent address for the database, regardless of where the app is connecting from.
Precisely. The listener provides that stable endpoint. And here's a key strategic tip. Keep the primary AG replica, the active database node, running on your existing VMs until your new containerized apps are deployed, stable, and proven healthy using those readiness probes.
Don't flip the database switch too early.
Exactly. Patience here is vital. Verify the new app deployment first.
Okay, so the app is ready in the container app environment, talking to the listener, but the primary database is still on the old side. How do you actually do the failover?
Right, the failover itself, it's typically a controlled manual step. You don't automate this usually, you trigger it deliberately. And you only do it after you've confirmed your new container app revision is healthy and ready. You'd use standard tools like SQL Server Management Studio, SSMS, or maybe the Azure CLI with SQL commands. Conceptually, you're telling the AG, okay, make this other replica, likely one running on a VM that's in the same VNet and accessible to your container apps, the new primary. It's a command that shifts the active role. The listener's IP address might change behind the scenes as part of this, pointing to the new primary node.
Okay, so you manually trigger the database role switch, but what about the application? Does it just freak out when the database it was talking to suddenly isn't the primary anymore?
Now this is the real aha moment for the application side. This is how you make it resilient. You absolutely configure your .NET application's connection string to use the AG listener's DNS name, not a specific server's name or IP. We covered that. But the absolute key, the magic setting, is adding multi-subnet failover true to that AD.NET connection string.
Multi-subnet failover true. What does that do?
It's incredibly powerful for this scenario. When you enable this property, the .NET SQL client driver becomes much smarter about handling failovers, especially in environments where the listener might resolve to multiple IP addresses, like in multi-subnet AGs or even during failover. Instead of just trying one IP, waiting for a timeout if it fails, and then trying another, the client actually attempts to connect to all the IP addresses associated with that listener name in parallel.
Oh, wow. So it finds the new primary much faster.
Massively faster. As soon as the failover happens and a new IP becomes active for the listener, the client connects almost immediately because it was already trying that connection. It doesn't get stuck waiting for slow DNS updates or long connection timeouts.
Okay, that sounds like the missing piece for seamlessness, like the app is constantly checking all doors.
That's a great way to put it. It dramatically cuts down the reconnection time, making the failover almost invisible to the application and its users. It's essential for that zero downtime goal with AGs.
Brilliant. So AG failover happens, multi-subnet failover handles the quick reconnection. What's next? Cutover.
Yep. The final steps involve verification and cutover. Once the AG failover is done and your new container app revision, which was already healthy, reconnects quickly thanks to multi-subnet failover, you start carefully observing. You might gradually shift traffic if you have that capability, or just closely monitor everything as the container app takes the full load. You watch SQL connectivity metrics, application logs, error rates, performance, everything.
Making absolutely sure it's stable before pulling the plug on the old VMs.
Exactly. Only when you are 100% confident that the new containerized application is running smoothly, handling the load, and talking reliably to the newly failed over database primary. Only then do you decommission the old VM-based application instances. Take your time, verify thoroughly.
That makes a ton of sense. It's a complex dance, but those pieces, the probes, the single revision mode, the listener, and multi-subnet failover, they seem to fit together perfectly. So, okay, migration done. Whew, you've moved everything over, it's running in container apps, zero downtime achieved. But how do you keep it running smoothly? Because zero downtime isn't just for the migration, it's for every update, every patch going forward, right?
Absolutely. The migration is huge, but it's also the start of a new operational model. And you want to bake that zero downtime capability into your day-to-day operations. This is where CI/CD, continuous integration, and continuous deployment becomes really important.
Automating the build and deploy process.
Right. You'll want to set up pipelines using tools like, say, GitHub Actions or Azure DevOps. These pipelines automate the whole flow. Every time a developer checks in code, the pipeline can automatically build the new container image, run tests, push it to your Azure Container Registry, and then, crucially, deploy it to Azure Container Apps using that same zero downtime, single revision mode strategy we discussed.
So every update uses the blue-green approach automatically.
That's the goal. You design the CI/CD pipeline specifically to leverage Container Apps' zero downtime features. This means future updates become routine, reliable, and importantly, non-disruptive.
Okay, CI/CD handles the updates. What about just keeping an eye on things, making sure it stays healthy?
Monitoring. Yeah, it's absolutely non-negotiable for ongoing stability. You really need to lean into Azure Monitor. It has specific capabilities for container apps, giving you insights into performance, resource use, logs from your containers. And you'll also want to use SQL Insights or equivalent monitoring for your database layer. This combination lets you track the end-to-end health. Is the app performing well? What's the latency to the database? Did the AG have any minor issues or failovers? Are error rates low? Having that continuous visibility helps you spot problems before they impact users and ensures you maintain that high availability promise long after the migration project is finished. It's about proactive management.
What a journey. Okay, so let me try and quickly recap the core ideas here. Migrating these critical stateful .NET apps without any downtime. It is possible. It seems to hinge on a couple of really powerful concepts working together. You've got the application layer handled by Azure Container Apps using those intelligent health probes and the single revision mode for that slick, automated blue-green deployment. That keeps the app itself updated smoothly. And then for the database, the linchpin seems to be the SQL Server always on AG listener, providing that stable connection point combined with that crucial multi-subnet failover true setting in the connection string, which makes the app resilient to the actual database failover.
That's a perfect summary. You've nailed it. It's about aligning the application deployment strategy, leveraging containers and smart platform features like container apps revisions, with the inherent robustness of SQL Server AGs. When you bring those two worlds together correctly, especially using the listener and that connection string property effectively, you really can achieve a smooth, genuinely uninterrupted migration from VMs to container apps, even for these really important stateful systems. It demonstrates how these modern cloud technologies can work together to maintain business continuity during significant infrastructure shifts.
It really makes you think, considering how vital database availability is and seeing how elegantly this strategy handles that transition. It kind of opens your mind, doesn't it? What other complex, stateful systems, things that maybe seemed impossible to migrate without downtime before, could this approach potentially unlock for you? Something to ponder. That's all for this topic. Stay tuned for the next deep dive.